Hello, this is Scholar Strive doing some math today, and algebra 2 we're going to be graphing logarithmic functions. So let's look at the parent here. So in last time we showed you our exponential function. Oops. And this is the line y equals x. And let me use two different colors here. So our logarithmic functions in red here are, and let's have our actual function in black. So what's going on here is that they're inverses of each other. So it has, you don't need to always draw the inverse, you just need to draw the logarithmic function. We'll practice many of those, but it has a vertical asymptote at x equals 0 here. Our domain is going to be x is greater than 0 with range all real numbers. So we're just flipping the x and y around. Okay, and this is for values greater than b. This is our exponential growth. If we have an exponential decay, so let's do red again. So we got this going on for exponential decay. What's going to happen? It's going to do this. It's going to do something like this. And it still has the vertical asymptote at x equals 0, x is greater than 0, and all real numbers for our range. Alright, well, how do we graph these? Alright, so we have y equals log base 3 of x. How do we do this? First, we're going to rewrite it as an exponential function. So base 3 to the y equals x. So 3 to the y, it's a y there, equals x. Oops. How do I get rid of this? There we go. Okay, and then we just choose some y values. So instead of normally choosing for x, we're just choosing our y values. So I'll choose some easy ones, 0, 1, and 2. So plug it in your formula. So 3 to the 0 is 1, 3 to the first is 3, and 3 squared is 9. Okay, just be careful when graphing, because I'm going to go x is 1, 0, then 3, 1, and then 9, 2. Okay, and there's my vertical asymptote at x equals 0. Alright. And it's not that bad. Okay, so let's do it again. So rewrite it as an exponential function. 1/2 to the y equals x. Okay. And I'm going to choose -2, -1, and 0. And the reason why I chose negative is because the fraction flips and the exponent becomes positive. So 1/2 to the -7th is 2 squared, which is 4. This becomes 2, and that becomes 1. So I'm going to go 1, make a dot, 2, -1, make a dot, 4, -2, make a dot, and see what's going on here is something that looks like that with a vertical asymptote at x equals 0. Alright. So those are some easy ones. Let's go to the harder function. There's the general function there. H, once again, if H is positive, then go right. If H is negative, go left. Positive K means up, down for negative. Okay, so you always want to use the opposite for your h value here, and I'll show you what it means. So x plus 3 means h is negative 3. Okay, oh, they have a spot for it. H is negative 3. K always tells the truth, so plus 1 means positive 1. Alright. So, how do we do these? So this is how it works. So we're going to go back to the parent function. So the parent function of this, like our most basic, is y equals log base 2 of x. Okay, so that is our most basic function here. Okay, that's our parent function. And now we're going to fill out a table like we did in the previous problems. So rewrite it as an exponential to the y equals x. Okay, and then we're going to make a table. So I choose y values, so 0, 1, 2. That'll give me, I'm just looking at this function here, to the y equals x. I'm not focused on all the other stuff yet. So to the y equals x. So if I plug 0 into this, I get 1. If I plug 1, I get 2. Plug in 2, I get 4. Okay. Now, we're going to translate, accommodating for our h and k now. Okay. So our h value is 3, and what we're going to do to it is take our x value that we just made, so 1, and we're going to either add or subtract h. It just depends on what h is. H is negative 3, so I'm going to do 1 minus 3. Okay, which is negative 2. Okay, and then y, you just add or subtract k. So this is 0 plus 1, which is 1. Okay, so let's look at the next one. And I'm just going to use a different color. So I have 2 here, minus 3, comma, 1 plus 1. So that is negative 1, 2. And then one more color here. Take my x value, 4, minus my h, and then take my y value, 2, and add my k. So 1, 3. Alright, now we can graph this. So our domain is actually going to be x is greater than negative 3. What affects that? My h value, because that shifts my graph left or right. In this case, it moved my graph 3 units to the left. So there is my asymptote. Okay, and then we fill out our numbers here. Negative 2, 1. Negative 1, 2. Oops. Yeah, negative 2, 1. Negative 1, 2. And then 1, 3. And it's going to look like that. Make it more curvy. Okay, our range is going to be all real numbers. So for all these logs, your range is going to be all real numbers. Your domain is going to be x is greater than your h value. So my h value in this is 2. So x is greater than 2. This one, my h value is 3. So my domain is x is greater than 3. Okay, so let's look at this. Parent function is y equals log base 3 of x. Change it. So that's 3 to the y equals x. Okay, now we're going to choose numbers for it. Y So choosing y's, easy y's to plug in. 0, 1, 2, 3 to the 0 is 1, 3 to the first is 3, and 3 squared is 9. Okay. Now we're going to translate. So 1 plus 2 this time. So this is 1 plus 2, comma, 0 minus 4. So I have negative 4, 3. Okay. This is going to be 3 plus 2, and 1 minus 4. So 5, negative 3. Okay, take my x value 9, add my h value. Okay, take my y value, and then add my k, which is minus 4. So minus 4. So 11, negative 2. Let's go ahead and graph this. So, always create your asymptote so x is greater than 2. So it approaches this line, but never touches. Okay, 3, comma, negative 4. Right here. 5, comma, oops, yep, 5, comma, 3. And 11, comma, 2. So it's doing this, and then doing that. Alright, so this is log of 1/3 of x equals y. So that would be 1/3 to the y equals x. K in this case is 0. Okay, so I'm just doing y plus 0 in this case, and this is going to be x plus 3. Alright, so I'm choosing easy values. I'm going to use negative 2, negative 1, 0, because if I plug in 0, I get 1. If I plug in negative 1, I'll get 3, and then 9 right there. Okay, 9 plus 3 is 12. 3 plus 3 is 6. 1 plus 3 is 4. And then these are going to stay the same. Because why? Because negative 2 plus 0 is negative 2, negative 1 plus 0 is negative 1, and 0 plus 0 is 0. Okay, graph these. So first we're going to make an asymptote at x is equal to 3. Okay, we know that when x is 4, we got 0. When x is 6, we got negative 1. And then if we got 12, it's 2. Okay. So most of these were inverses of exponential growths, except for this last one, which was an inverse of an exponential decay. Hopefully this helped you out. Have a good one.